when we simulate simple experiments, we conduct an experiment that models a real-life situation, and usually we do it because it's not convenient to actually do the experiment. For instance, we might ask, what is the probability that the next 5 babies born at a hospital will be girls? Well, who wants to go and sit around at the hospital and wait for the next 5 babies to be born? So when we simulate it, and to simulate it, we can use many things. We could use a coin, because that's boy, girl. And if we use a coin, we have to decide before we start flipping if heads is going to represent boys or if heads is going to represent girls. And it really doesn't matter, you just decide ahead of time. So I'm going to say heads is boys, tails is girls. And then the simulation would be flipping the coin 5 times and see how many tails in this case we get. And if we get 5 tails in a row, that would be 5 girls. If we only get 3 tails out of the 5 flips, that would be 3 girls. Or 3 out of the next 5 would be girls. And you might perform that simulation over and over again to kind of get an average of how likely it is that it would be 5 girls. Now, what other things could we use? Because the coin might be the most obvious, but could we use a 6-sided die? And how would we use it? Because we can. All we need is an equal number of things to represent boys and an equal number to represent girls. So you could do 1 through 3 is boys and 4 through 6 is girls, or the odds are the boys and the evens are the girls. That's probably the 2 most likely. And then we would roll it 5 times. So other things that we could do, we could use a spinner. Now that spinner could either have 2 sections, and one side would be boys and one side would be girls, or it could have 4 sections, and you would designate like maybe the opposite ones to be boys and the opposite ones to be girls, and spin it. It could have 6 sections and so forth. I mean, you're getting the drift, right? And then obviously they should be in the same size. We could also put marbles in a bag, same number of blue and the same number of pink, if you want to go that way, and pull them out 5 times. And of course here we would spin 5 times. But I just want you to start thinking, what could I use? What do I have handy that I could use? Now, something that I want to make my way around to is talking about a random number generator. And these are everywhere now. We have them on the calculators we use in class, which are TI-30 Roman numeral 2XS or something like that. It's under the PRB button. And then you arrow over to RAND-I, which means random integer. And when you hit enter on that, what will come up on your screen is RAND-I with a parenthesis on it, and then you put what you want. So in this case we would put a 1, 2, and the comma is right above the right parenthesis which I just drew. So on the calculator you have to use the second function button to put in that parenthesis, but then you hit enter, and as soon as you hit enter it will randomly give you a 1 or a 2, and before you hit enter you have to designate whether 1 represents boy and 2 represents girl, or 1 represents girl and 2 represents boy. It really doesn't matter, you just have to decide and you would write it down. So if I were going to do this, I'd probably make, usually what I'm looking for, I make 1. So I'd make, since I'm looking for girls, I would make 1 a girl and 2 a boy. And then press the enter button 5 times and see how many times it came up girl. I have also looked at a place called random.org, and it gives you two screens, or like 2 boxes, and it gives you a min and a max box. And just like these numbers right here, just like these numbers right here, these represent your min and your max. There we I can't seem to get. There we go. These represent your min and your max. Also, Excel has this as well. I think you can start typing in random, and I think it's rand between. So Excel, it's rand between, and as you start to type it in, it'll give you some options. And so if you have Excel on your computer, you can pull that up, and it will, again, you have to put in parentheses your min and your max, and then it'll randomly give you a number between and including those numbers. Now I want to talk about how we find the probability of these experiments. So theoretical probability we write as capital P sub t, and then the event, whatever it is, like in this case we were looking for a girl, we would put P sub t girl, and this equals, and this is again the theoretical, not what we're doing today, but I need to tell you the theoretical before I tell you the experimental. The number of successes over the total number of outcomes. So in our example of a girl being born, we'd put P sub t girl, and there's only one girl out of two options, which is boy and girl. So the theoretical probability of one kid being born is 1/2. 5, we're going to talk about, that's compound probability, and we'll talk about that later. Experimental probability is P sub e. So it's P sub e event, and I should have had a T up here, I put one on now. The number of times the event occurs over the number of trials. So in this example where we were either flipping a coin or spinning a spinner, whatever it is, it would have to be how many girls we actually got. So if I flip the coin and I get 3 heads out of the 5 flips, then it's 3 out of 5. So no longer is the bottom number a 2 because boy and girl. That's the theoretical. With experimental, it's how many trials we performed, how many times we flipped the coin, how many times we rolled the die, how many times we spun the spinner. I want to talk about one more example, and that is something like guessing a multiple choice test or free throws where you might make or miss it. Let's talk about a multiple choice test that has 4 answers. Those 4 answers, A, B, C, and D, and there are 10 questions. Well, you might think, well, we need something with 4, right? So a coin's not going to work. A die doesn't really work unless you have a 4-sided die. Or if you go ahead and use the 6-sided die and you just count 1, 2, 3, and 4, and then every time you roll 5 or 6, it doesn't count. You have to re-roll. But again, the easiest thing here is going to be to do random integer 1, 4, or go to random.org and put your min 1 and your max 4. But 1 through 4 does not represent A, B, C, and D. That's what we usually think at first. But which is the correct answer? We don't know, right? We don't know if A is the correct answer, or if B is, or if C, or if D is. And A is not going to be the right answer to all 10 questions. It might be the answer to 1 of them, or 2 of them, or 3 of them. Okay, this is what I'm getting around to. Our 1, 2, 3, and 4 have to represent, well, this is the question, how many right answers will there be? There's only one right answer or correct answer, and there are 3 incorrect answers, right? So number 1 would represent, or number 2 or number 3 or number 4, if your favorite number is something else, you could choose any one of them. I'm going to go with 1 is going to equal my 1 right answer, and 2 through 4 are going to represent an incorrect answer. So when I put in, if I go to PRB and I arrow over to rand I, and then we enter that in the parenthesis 1, 4, and then as soon as I hit enter or equals, it will give me a random number 1 through 4. And if it's a 1, that means I guessed number 1 correctly. If it gives me a 2 or 3 or a 4, that means I guessed number 1 incorrectly. But then you would hit enter 10 times to represent the 10 questions, and you would write down which number you got every time that you hit the enter button. And that would simulate guessing a 10 question quiz, multiple choice, with 4 options and only 1 right answer.